We're about half a week into the COVID lockdown here in Paris. I figured it's as good a time as any to try and encourage students to do some homemade science with things they can find around the house. This activity is based on, this activity is inspired by two science snacks from the Exploratorium Teacher Institute, Poking Fun at Light and Personal Pinhole Theater. If you have access to more materials, I strongly recommend you check out their versions of this. When I first experienced the Personal Pinhole Theater at the Exploratorium, my mind was blown. So immediately I got to thinking about how I could scale this down with smaller, simple materials that it's easier to stock in a crowded Paris staff room or storeroom. Okay, so to get started, the materials you'll need 2 toilet paper rolls, ideally of different brands. Brands aren't standardized, so they'll be slightly different diameters and can fit into another. If you don't have one that's appropriate, you could always run out, buy some more toilet paper, even without taking the roll out. You can use it like that. Or you could use paper towel rolls. Well, that one's quite a snug fit. Or really any cardboard rolls you find around. Okay, so paper towel rolls. Then you'll need some aluminum foil and some baking paper. Some places it's called parchment paper. Wax paper works just fine like this, whether or not it has a wax coating. Or anything that's semi-transparent and thin. I've also had a lot of success with semi-transparent plastic bags. You can see I cut a square out for a pinhole camera there. And elastic bands to hold it on, and something small like a pencil with a sharp tip, or a small nail or pin to poke the hole. Okay, so to get started, I've already pre-cut a square of aluminum foil. I'm going to take my smaller toilet paper roll, put it on the end there. So it's nice and tight, and then the baking paper. Try and keep the baking paper as flat as possible for this part. It'll form the screen where your images are formed. And then I'm just going to take the baking paper end and insert it into my other tube. So I'm ready to look through like that. And I'm just going to poke a small hole. I'm going to start small and can always make it bigger afterwards. So just a small hole, and now I can look through the pinhole and I should see an image on this screen. Okay, now that it's made, let's go test it out. Now I'm outside at Place de la Bastille in Paris to test out the pinhole. You'll see as I bring the viewer up to the camera, it's dark for a second as the camera adjusts. You'll find the exact same thing with your eyes, but it might take even longer, as much as 10 or 15 seconds for your pupil to dilate, you to be able to see what's on the screen. Notice as I move the viewer around, we see an upside down version of the world around us. It's actually upside down and backwards, and you can notice things like the blue sky at the bottom of the image, followed by buildings and street level with cars and pedestrians going by backwards in relation to how they would be in the real world. You'll also notice there's a trade-off for the size of the hole versus the brightness of your image. The bigger the hole you have, the more light it lets in, but the less clear the image. Now let's go back to the lab and check things out. Okay, now I'm back inside to go over an explanation of why the image is upside down and backwards. Okay, now to model what's happening inside the pinhole, I'm using a giant version just of the hole for now. And I'm going to look through that hole at an image now of 3 colored points. So I'm going to line this up, so right now I'm just looking at the blue. Note that the green dot is on the right, and if I want to see that through the hole, I need to move the camera or my eye to the left. If I want to see the red dot, which is on the left, I need to move things over to the right. So we see this apparent inversion through the hole. If we were to put a screen up on this side, and if the dots were bright enough to project onto the screen, then we'd see the green dot over on the left and the red dot over on the right. So that's a quick demonstration of how light traveling in straight lines gives rise to this inversion of images. The same thing happens vertically. Now this is going to be a little bit messy, turning my computer vertical near the edge of a table. And same thing, if I want to see the green dot which is on top, I need to move the camera downwards to get to the green, and to see the red which is on the bottom, I need to move the camera upwards. So we're seeing this inversion both left, right, and front, back. And that's just the beginning. There's many other things you can do with pinhole cameras. Try, for example, adjusting the size of the hole, poking multiple holes, and see what happens. Now that you've seen how to make your very personal pinhole theater, it's up to you to get materials and go make this. Throughout the confinement, I'll be trying to make more videos of interesting hands-on science you can do with things that should be lying around your house. So please check back for more videos. And don't let the lockdown stop you from having some fun with hands-on science.